All right, y'all. We're looking at the 3-10 notes, solving quadratic equations by graphing. Okay, so the first thing I want to draw your attention to is the name of this section of notes. We are not necessarily dealing with just straight up talking about quadratic functions anymore. Okay, what we're dealing with is solving quadratic equations. Okay, so that means we're not just talking about the parabola that a quadratic function makes anymore. We are talking about, instead of y equals x squared and everything, we've got a number equals x squared and everything. Okay. So let's talk about it. Okay. You can find the solutions to an equation. Okay. You can find the solutions to an equation that looks like this if you graph the left side of that equation as a function. Okay, let's talk about it a little bit. Okay, this is something you learned. This might ring some bells back in Algebra 1. Okay, solutions and roots and zeros and x-intercepts is four different words that are all referring to the same thing. Okay, in fact, back in Algebra 1, that's a very popular thing to put on the STAR test, is to have like three different versions of basically the same question, except one of them calls them roots, one of them calls them zeros, and the other one calls them solutions. Okay, so let's talk about it. Okay, when you graph a parabola, there are three different ways you can look at it. Okay, when you graph, okay, so you know what? Before we get into that, here let me give you the rundown of basically what we're doing here. Okay, the idea is that if you can arrange a quadratic equation to where all of the stuff, all of the ax squared plus bx plus c is on one side of the equal sign, and there is nothing else left on the other side of the equal sign, you can graph this part as a function, y equals all of that, and you can look at the parabola and figure out what the solutions are to this equation. Okay? So if you graph the function that is related to this equation and then figure out stuff about that parabola, you can find the solutions to the equation. Okay? There are three different ways it can go. When you graph your parabola, one way it could look like, the most common way that it looks like, is that the parabola crosses the x-axis and has two x-intercepts. Okay, a parabola in that fashion would look something like this, just for example. Okay, you'd have one x-intercept right there and one x-intercept right there. And if you find the x-coordinates of those intercepts, you find the solutions to the equation. Okay, so that's the most common way you're going to see it. Most of the time, there are two solutions to a quadratic equation. Okay, it is also possible that you could only have one x-intercept and therefore one solution. Okay, a parabola in that fashion would look like this. It would come down, and that vertex would be right on the x-axis, and then it would immediately peel back off and go up. So it only actually touches the x axis at one single point. So there's only one single solution. The other way that this could go is that there would be no solutions. And if there are no solutions, what that means is that the parabola has no x-intercept. So it would be something like this right here. Something, a parabola like that, never crosses the x-axis. So the equation that goes with that parabola would never have any solutions. No real numbers would ever fit. Okay? So, something I want you to remember before we get into the details of how to do this in the calculator, something I want you to remember is is what it means for a number to be a solution. Okay? If a number is a solution to the equation, that means you could take whatever number we get as our answer and plug it back into this original, and it would make this a true statement. Okay, so as we go through example number one, I'll walk through the steps that we use in the calculator. Okay, the first thing we need to do is make sure that you have all of the quadratic on one side of the equal sign and zero on the other side. Okay, make sure you have quadratic equals zero. Okay, on problem number one, that step is already done for us. We have everything on the left side and nothing on the right side. It's just straight up zero on the right side. Okay, So the next thing we're going to do is enter the left side of that equation into y equals in the calculator. So we have y equals, we're going to enter this function, x squared plus 2x minus 3. Okay? You can see on the graph of this, okay, it makes a nice, lovely little parabola. And when you look at this parabola, you can see that we've got two different x-intercepts, right? Those two different x-intercepts are going to represent two solutions to this equation. Okay? Here's what we're going to do. We've entered that function into y equals. We're going to hit second trace, this button right up here, and option number 2, you see it says 0. Okay, that's the name that the calculator used for it. Okay, remember, solutions, roots, and zeros, all naming the same thing. It's x-intercepts, right? Okay, so we hit 0. And what we're going to do, the first thing that pops up is left bound. So the first thing I'm going to find, okay, the goal of what I'm trying to find here is this x-intercept. Where is this x-intercept located? So when it says left bound, I'm going to scroll over my little cursor somewhere to the left of that x-intercept and then hit enter. Then I'm going to scroll somewhere over to the right of that x-intercept where it says right bound and hit enter again. Now I'm going to scroll my cursor as close as I can get it to that x-intercept. It's usually not going to be right on top of it, and hit enter again. What it gives me is 0, x equals negative 3, y equals 0. What that means is that this point, negative 3 comma 0, that's where the x-intercept is. And what that also means is that one of the solutions to this equation is x equals negative 3. Now think about what it means, like I said a minute ago, to be a solution. Okay, if I say that x equals negative 3 is a solution, that means if I take negative 3 and plug it in right here, okay, we substitute that in for x, that's positive 9 minus 6 minus 3. Well, what is 9 minus 6 minus 3? It's 0, just like this equation says. That should be equal to 0. Okay, so negative 3 is something that fits into this equation. It is a solution, just like it was an x-intercept over here. Okay, come over to this. Next thing I want to do is find this x-intercept. Okay, we already found this one was a negative 3. We want to find what this one is. Okay, I'm going to hit second trace 2 again. Scroll over. We start by putting our cursor somewhere to the left of that x-intercept. Hit enter. And then I'm going to move my cursor somewhere to the right of the x-intercept. Y'all, it doesn't matter how far to the left or how far to the right you are, as long as that's where you are, on the left and on the right. It doesn't matter how far or how close, as long as you are to the left and to the right. Then you're going to scroll over and get as close as you can. Hit enter one more time. This time it gives us a value of x equals 1. That means x equals 1 is also a solution to this equation. Now look at that. Okay, check your work. If you're not sure about these answers, check your work. If we plug in x equals 1 into this equation, that's 1 plus 2 minus 3. Well, what's 1 plus 2 minus 3? It's 0. Okay, so that tells me that x equals 1 also fits into this equation. Okay, since that also fits, we're all set. We've got our two solutions because we were able to find our two x-intercepts. All right, take a look at problem number 2. Okay, you'll remember at the very beginning of all these problems, something that we're looking for is we need our quadratic to be equal to 0. Okay, unfortunately, we have a bunch of stuff equal to 25 in problem number 2. So the question is, how do we get rid of this 25? How do we turn 25 into 0? We subtract 25. Remember, though, your golden rule of algebra, right? Your golden rule of algebra, what you do on one side of the equal sign, you must also do to the other. Subtract 25 on this side also. Okay, on the right side, it goes away. It's 0, which is what we were looking for. And you'll notice on the left side, I'm not putting any of these things together. Okay, the question, why did I not combine negative 25 with the x squared and 10x that were already over there? And the answer is that they're not like terms. Okay, you cannot combine things that are not like terms. It's just like the offspring said, you got to keep them separated. Okay, so now that we've got it equal to 0, This right here, this down at the bottom, is something that we can put into the calculator. Okay, actually here. This right here, that's what we're going to put into the calculator. We hit y equals, clear all that out, negative x squared minus 10x minus 25. You can look at the graph of this one. See, this one is flipped over upside down. You can see this one opens downward, just like we talked about in the previous lesson. We've got a negative out in front of x squared, so we would expect it to open downward. Okay? You can also kind of see that this one only touches the x-axis just at this one single spot, right? Okay, what that means for us is that when we find the solution, there's only going to be one of them. Our final answer is not going to have two parts the way this one did. It's only going to have one single solution. So we hit second trace 2. We scroll our little cursor until it's somewhere to the left of that x-intercept. Then we scroll that little cursor till it's somewhere to the right. We scroll it up until it's real close as we can get it. And we hit enter and it gives us this value right here. X equals negative 5. And since there's only one x-intercept, there is only one solution. X equals negative 5. Roll on down to number 3. Okay, I want to take a second and just think back to what we did at the beginning of the 6 weeks. Okay, we were factoring stuff that looked like this. I want you to imagine that we didn't have the equals 0. Okay, we just had x squared minus 6x plus 8. And all we were doing was factor this polynomial. Well, then, if that was the case, we'd be looking for two numbers that multiply to positive 8 and add up to negative 6. And our two numbers would be negative 4 and negative 2. Okay, those two key numbers, negative 4 and negative 2. I want you to keep that in mind when we come back around to our final answer. Okay, we're going to enter this into the calculator and find our answer the same way we've been doing these other ones. All right, x squared minus 6x, there we go, plus 8. You can look at that graph. It's going to give you a lovely looking little smooth, nice curved parabola right there. We hit second trace 2, just like we've been doing. Scroll our cursor. I'm going to find this x-intercept first and then find that one. Okay, we scroll to the left, and then we scroll to the right, and then we try and get as close as we can. And that gives us one of our solutions. One of our solutions, x equals 2. Then we're going to do the same thing, second trace 2. Scroll somewhere on the left, and then we scroll somewhere on the right, and then we try and find that x-intercept exactly on it, and we've got x equals 4. Now I want to take a second, okay? Just a second ago, we said that if we were factoring that expression, if we were factoring this expression that we started with, our two key numbers that multiplied to 8 and added negative 6 were negative 4 and negative 2. Well, our solutions are positive 4 and positive 2. Funny how that works, huh? Funny how that worked out, okay? That's going to be in the next lesson. All right, just keep that in the back of your mind for when you go on to the next lesson. That's going to be in there. All right. This last one, problem number 4, is something that has to be fixed. Okay, all of our stuff, all of everything, the x squared, the x, and the x squared, the x, and the constant all have to be on the same side of the equal sign. Okay, so what I'm going to do is I'm going to subtract 11x, and I'm going to subtract 28. I'll do it all in one big step. Okay, we're going to do it on both sides. We do it on both sides. All of that goes away. We've got 0. And then we've got negative x squared minus 11x minus 28. That's what we put in the calculator. On the graph, you can look at that and tell with two x-intercepts, we're going to expect two solutions to this equation. Okay, so we hit second trace 2 just like we've been doing this whole time. I'm going to go to the left of the first x-intercept. Then I'm going to go to the right of the first x-intercept. And then I'm going to guess, try and get as close as we can. Our first one is -7. Ooh. There's one of them. And our other one, second trace 2, one more time on the left side of it and on the right side of that intercept, and then right on top of it as close as you can get. X equals -4. All right, that's all we've got, okay? All we're trying to do here is remember our key fact that x-intercepts represent solutions to quadratic equations. All right, that's our key fact for the day. Okay, so if you can mess around with the graph of a graph of a quadratic in a calculator, you can find the solutions to that equation. All right, that's all we'll have for today. Everybody have a good one.